All right, class. So section 4.2 is about binomial distributions. So this is just a type of a probability distribution, and it is a discrete distribution because it is countable. So a binomial experiment is an experiment that's repeated for a fixed number of trials, where each trial is independent of the other trials, and there are only two possible outcomes of interest for each trial. The outcomes can be classified as success or failure. A lot of times the determination of success or failure is arbitrary, which one we count as success, which one we count as failure. So for example, sometimes it's obvious if I'm looking at something like the probability I'll get a disease or not. Not getting the disease would probably be the success, right? But other times, like I'm flipping a coin, so I'll arbitrarily decide that either heads or tails is a success, and the other one would be the failure. So usually when you're doing these for your homework, whatever they give you the probability of, you're going to count that as a success, even if you think that really should be the failure, and make that your P. The probability of success is the same for every trial, which also means the probability of failure is the same for every trial. And the random variable X counts the number of successful trials. So let's suppose that I decide I'm going to toss a coin 10 times, and then I'm going to count the number of times I get a head. The probability, so each trial is independent of the other trials. Every time I toss a coin, it's independent, right? The probability of getting a head is 0.5. The probability of getting a tail is 0.5. So my probability of success is 0.5. My probability of failure is 0.5. And X would count the number of successes. So if I toss the coin 10 times, I could have 0 successes. So I could get all tails all 10 times. I could get 1 head, 9 tails, 2 heads, 8 tails, right? I could get 3 heads, 4 heads, 5 heads, 6 heads, 7 heads, 8 heads, 9 heads, or 10 heads. So I could have all successes. The probability of that is really small, that I get no heads or 10 heads, but it is a possibility. So the binomial distribution, the notation that we use, N is the number of times the trial is repeated. So in the example I gave, N is 10. P is the probability of success. So in this case, my example wasn't so great because I used something where the probability of success is 0.5. But let's suppose instead that it was rolling a die, and that I considered a success rolling a 6. Okay, so that would mean the probability of success is 1 out of 6, or 1/6. And the probability of failure would mean that I get a 1, 2, 3, 4, or 5. And the probability of failure is 5, 6, or 1 minus P. And X would represent the number of successes in N trials. So if I rolled that die 10 times, I would count the number of times that I rolled a 6. And that number could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Okay, so the way that we calculate the probability of getting X successes is the probability of X is, this is from the last unit, N combination X, P raised to the X, Q raised to the N minus X. So let's look at what happens, the probability that we got 0 successes. Okay, so if I get 0 successes and I'm going to roll the die, try to get a 6, the probability that I get no 6s is going to be 10, choose 0, P raised to the 0, Q raised to the N minus, so N was 10, so sorry, 10 combination 0, P to the 0, Q to the 10, and that equals 10 factorial divided by N minus 0 factorial. This is also 10 factorial, these cancel. 0 factorial is 1, so this all becomes 1. P to the 0, that also becomes 1. q to the 10. So the probability that I don't get any 6s is in 10 trials is going to be 5/6 raised to the 10th, which makes sense, right? Because they're independent trials. So it's just q to the 10th. The probability I get 1 success is going to be n combination 10 combination 1, p to the 1, q to the 9. And so that time I would get 10 factorial over 10 minus 1 factorial, which is 9 factorial. So 10 factorial is 10 times 9 factorial over 9 factorial. So this gives me 10. So 10 over 1 factorial. So that's just 10. 10 times p to the 1, q to the 9. So this is 1 success, 9 failures. And then 10 are the number of ways that that could happen. And that makes sense because my 1 success could have happened on the first trial, the second trial, the third trial, the fourth trial. So there are 10 possible ways that that can happen. So that's where this comes from. All right. So n is the number of trials. P is the probability of success. Q is the probability of failure, which is 1 minus p. X is the number of successes in n trials, and X is a random variable. And then the number of failures, notice, is n minus X. If I have X successes, I have n minus X failures. So that's where this formula comes from. But I'm going to show you in Excel how to do this. I'll show you how to put this formula in, but we're going to do it without this formula because Excel has a built-in formula for the binomial distribution, which is a lot easier to use. So here's how you create it. So the way that you create a binomial probability distribution is you're going to list all the possible values of X with the corresponding probability of each. So here they gave one with n equals 3. So, and with the binomial probability distribution, we can have 0 successes. So sometimes the distribution won't allow for a 0, but here X can equal 0. So we're going to start with n equals 3, and the probability of 0 successes with p equals 0.34 is 0.016. 1 success, 0.141, 2 successes, 0.422, and 3 successes is 0.422. And when we add all these together, they're going to sum to 1. Okay, so you use this binomial formula here to find the probabilities. So we're going to recreate this table in Excel so you can see how to use it. And then to calculate the mean of a binomial distribution, it's a lot easier because it's just, you don't even have to create this table at all. The mean is n times p. So if you have n and p, you can calculate the mean. The variance is npq, and the standard deviation is just the square root of the variance or the square root of npq. So that's the end of the material for this. So let's open up Excel and we're going to recreate this. And then I'm going to show you how easy it is to find the mean, variance, and standard deviation from that. All right, so let me open up my Excel spreadsheet. All right, so I have in here chapter 4. I'm just going to scroll down. And we're going to add in next our binomial distribution. Okay, so I'm going to start with their example. So they had n equals 3 and p equals 3/4. Okay, so let's first create our table. So we have X, and then we have P, X. Right, so X can be 0, So an easy way to increase your numbers in Excel is you go equals, take the previous number and add 1. So this is an easy way to create consecutive numbers. This is also how we create consecutive numbers in a computer program. Shoot, let me just pull this down. So you just use the previous number plus 1, and when we copy that formula, right? So this is the same way you do it in a computer program. And then the P is 3/4. And then, so our formula, so let me put in for this, I'm going to insert some rows here. So if you right click, you can insert. Okay, so I'm going to change this and put this in like this. N is 3, P is 3/4. Shoot. Doesn't like it. Now it's going to make it a, to fix that. Otherwise it keeps trying to make it, you have to go equals 3/4. I think that'll fix it. There we go. And then Q is 1 minus P. Okay, so we put these two things in. So I'm just going to make those red. All right. And then Q is calculated. And then the formula for the binomial distribution is this. So remember, it's equal common, right? And then it's the number 3, the number chosen 0, and then we're going to multiply that times P raised to the X times Q raised to the N minus X. That should have said Q. Okay, so if we put in our NPQ, and this is again how we do this using the formula here. So this is the combination of N, choose X, and I'm going to anchor the N. P, times P, this one, I'm going to anchor that to the X times Q, I'm going to anchor that, raised to the N, I'm going to anchor the N minus X. Okay, now I should be able to show you that that matches. Okay, and now I can take this formula and I can copy it. All right, so this matches their table. If I change this to 3 decimal places. Okay, so that's one way to get these values. Another way to get these values, which is way easier, is I go equal, and Excel has built in a binomial distribution. It's Binom.DIST. Hit the tab button, it'll pick up that formula for you. Okay, and then we put in the number S. So this is the number of successes, that's X, comma, and then I put in the number of trials, that's N, comma, and then I put in the probability of success, that's P, comma, and then this is whether we want the cumulative distribution or not. Remember the cumulative distribution, it would give me the probability of X plus all previous things. So this time it would just give me the probability of 0 successes. But if I use this for when X is 1, it'll give me 1 success or 0 successes. And I want this to only give me this one. I'm looking for PX exact, not cumulative. So I'm going to put in false. And there we go. And now let me also make this one to 2 decimal places. And I'm going to write this formula above here for you. So it's equals, actually, let me copy this. I want to copy the actual formula. I don't want the numbers to change. So this should match this exactly. So, and you saw I copied that from within here instead of doing Control C, because if I Control C, it'll change the location. So this is what this looks like. I just want to change this so this reflects how we do this. This is X N P. Okay, so that's what we put in. X N P false. All right, so now if we anchor, we want our X's to change, but we want to anchor our N. I only need to anchor the row location because I'm just going to copy this down. And I want to anchor my P, so it doesn't change those. And now I can just copy this formula down. So it's a lot easier to use this. Binom.DIST. Again, it's going to be X. When you look here, number of successes, X, number of trials, N, probability of success, P, make cumulative false. Okay, and then if you anchor the N and the P, then you can just copy your formula down. And so this gives me the same answer. All right, and then to get our mean and our variance, to get the mean, it's NP, and the variance is NPQ, and the sigma is the square root of the variance. Okay, so to get the mean, we go equals N times P. To get the variance, we go equals N times P times Q. And to get the standard deviation, we do equals square root of the variance. All right, so let's go look at the homework. Bear with me a second. Okay, so this is Unit 3, Assignment 1. All right, and we can now do numbers 6 through 8. So I had to find one. Okay, so 39% of adults favor the use of unmanned drones by police agencies. 12 US adults are randomly selected. Find the probability that the number who favor is exactly 3, at least 4, less than 8. All right, so to do this one, I am going to, first of all, let me copy my problem. All right, so this is number 7. Okay, and my problem says that 39% of adults favor the use of unmanned drones by police. So I'm going to go up here and just copy at least a little bit of my formulas to get this, make this easier for me to set up. Okay, so for this is a binomial distribution. And I'm just going to copy this part of it. Right, and then I'm going to change my, let me also, it's okay, we'll redo it. So my N is 12. Okay, 12 US adults are randomly selected. The 39%, that's my P. So my P is 39% over 100%, right? Gives me this as a decimal, which I need. So my Q is calculated 0.61. Okay, and then, so my probability that X is 0, this should pull, it's pulling from up above. It's not pulling from this one. So I'm not going to do it this way. Let me take this one out. Okay, we're going to just do the binomial distribution. So we're going to go equals Binom.DIST. And then it's X, comma, N, comma, P, comma, false. Okay. And then again, I want to anchor. So X, comma, N, comma, P, comma, false. And I want to anchor my N and my P. And then this is 0 plus 1. Now I can copy this down to get my 12. Okay. Most students go ahead and make this where it'll do more than 12 in case you get more when you do a quiz, and that's fine. And then I want you to see what happens when I calculate the probability beyond 12. So you'll notice that when I get beyond 12, it just gives me an error. Okay, there is a number in here. It's just by rounding that's making it look like there's nothing. So there are values in these cells. It's just the probability of getting 12, 11, or 12 is really small. And that's because our P is less than, our P is less than 0.5. So when the P is smaller, the probability of getting, it's always small for these anyway, like the probability of 0 is small. But when our P is small, these numbers will be really small. When our P is large, these probabilities will be small. All right. So that's how we calculate the probability distribution. So what we've created here is our whole probability distribution. I'm just going to pick one to show you that this is working. Binom.DIST, X, N, P, false. Okay, so now it asks me P3, that's this one. This is probability that I get 0 successes, the probability I get exactly 3 successes is right here, and they want it to 3 decimal places, so it's 0.153. Okay, and now they want the probability x is greater than or equal to 4. I'm just going to put out here, this is equals p 3. Okay, whoops. And then they want the probability that x is greater than or equal to 4. P3, I can just go grab the one. It's this one. The probability that x is greater than or equal to 4. Okay, so that means that x can be 4, 5, 6, 7, 8, 9, 10, 11, or 12. So it's going to be equal sum, and I'm going to add up from 4 to 12. 4 is included. Again, so I'm just summing from 4 to 12, all my probabilities. And that one is 0.753. Okay, and then next, it wants x less than 8. For that one, x can be up to 7. It doesn't include 8, so that includes 0, 1, 2, 3, 4, 5, 6, 7. This is honestly the easiest way to do these. So if you look at what they show you in the textbook, so here, make sure that you grab the right ones, 0 through 7. So if you look at what they show you in my stat lab, they're going to use the cumulative. They're going to change cumulative to true. And so I can get for less than or equal to 8. I just want to show you that's the same as using the cumulative distribution for 7. So I'm just going to type it in so you can see. So if I use 7, because that would be less than or equal to 7, n is 12, and the probability was 0.39. So if I put it in like this, oops, and then I put in true, that gives me the same answer. Okay, so that's how the cumulative distribution works. So for this one, I could calculate the probability for x less than 4, which would be the complement of this, which would use the cumulative distribution for less than or equal to 3, and then subtract that from 1. So that's the other way that I could get this. So I just wanted to show you that as an example. That's how you use the cumulative distribution. But the easiest way to solve these is just, since we're using Excel, create the entire distribution and then just grab the parts that you want. So less than or equal to 8 is 0.951. Okay, and then that was the end. Oh, wait, one more. Let's see. So this is just asking you, oh, this time they're asking you for the mean. So I'm just going to go back and do it for this problem I've already put in. So if you also add in here the mean, let me just put that up at the top. Mu, remember mu is NP. So it's equal N times P. And then our standard deviation, or our variance, sigma squared, is N times P times Q. And then sigma is just the square root of the variance. Okay, so now when you go to the next one, and it's asking you, you randomly select 6 adults and ask them why they think this is a problem. Find the mean. So now I can use this same thing and I can just change this to 6. And my probability is 0.78. Not only did it calculate my distribution, so if they ask me a probability question, and notice these are missing now because they're bigger than n, but here's also my mean to the nearest 10th, 4.7. My variance to the nearest 10th, 1. And my standard deviation to the nearest 10th, that's also going to be 1. All right, and then most samples would differ from the mean. So remember, typically we would be within 1 standard deviation from the mean. So we would differ from the mean by no more than 1. All right, so that's the end of 4.1 or section 4.2, and you can now complete numbers 6 through 8.